Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about reciprocal and inverse function. A reciprocal function is a function that can be inverted. For the reciprocal of a function, we alter the numerator with denominator of the function. The function of the form, that is the function of the form f of x equal to k over x, can be inverted to a reciprocal function as f of x equal to x by k. For example, reciprocal function can be written as 1 over x. Here, in reciprocal function is undefined when x equals 0. Look at here, if x equals 0, if you put it become 1 by 0, it's infinity. So at x equals 0, a reciprocal function is undefined. That means we cannot define that function when x equal to 0. Look at this figure. Here, this is a curve. It won't touch the axis x and y. Whenever you go beyond the origin, it nearer to axis, but it won't touch. Here also, look at here. What is asymptote? An asymptote is a straight line that constantly approaches a given curve but does not meet at any infinite distances. In other words, asymptote is a line that a curve approaches as it moves towards the infinity. The curve visits these asymptotes but never overtaken them. Look at it here. This curve is extending like this is a asymptote line, but whenever you go beyond the origin, that is the curve is extended, but it never touch the line. So that line is called a asymptote. Now let us do some example for asymptotes. Look at here. Determine the equation of the asymptotes. The curve f of x equal 3 over x minus 2. If you give x equal to 2, it approaches 0, that is 3 over 0, it's infinity. Put x minus 2 equal to 0, which gives x equal to 2. So, therefore, vertical asymptote equal x equal to 2. Now, for horizontal asymptote, you have to keep this one is y, f of x equal to y, 3 over x minus 2 by cross multiplying y x minus 2y equal to 3, then yx equal 2y plus 3, then x equal 2y plus 3 over y. Here, look at this function x equal to 2y plus 3 over y. It's an inverse function of this one. Then if you approach y equals 0, it gives infinity value. Therefore, put y equals 0, then you can say if you put y equals 0, 3 over 0, it's therefore x equal to 3 over 0, it gives infinity. Therefore, y equals 0 is y equal to 0 is horizontal asymptote. Similarly, one more example. 2 minus 3 over x plus 1. So which is equal y, because f of x, you can keep it as y. For this, we put x plus 1 equal to 0, then which gives x equal to minus 1. So x equal to minus 1 is a horizontal asymptote, vertical asymptote. X equal to minus 1 is vertical asymptote. For horizontal asymptote, look at here, 2x plus 2 minus 3 over x plus 1. That means I take LCM x plus 1, which gives 2x minus 1 over x plus 1, which give by cross multiplying yx plus y into 1 is y equal 2x minus 1. Collecting y one side, yx, that is x form, minus 2x minus y minus 1. Here, no, take x one side, sorry. This is 2x. So, x equal to y minus 2 minus y plus 1 over y minus 2 when x equal minus y for y minus 2. Similarly, this x equal to minus of y plus 1 over y minus 1 is a reciprocal inverse function of this. Then we can see if you put y equal to 2, then it becomes infinity because denominator becomes 0, so x become infinity. Therefore, horizontal asymptote is y equal to 2. Now, here, next we consider inverse function. What is inverse function? In mathematics, an inverse is a function that serves to undo another function. That is, if f of x produces y, then putting y into the inverse of f produces the output of x. Then a function f that has an inverse is called invertible, and the inverse is denoted by f inverse. Now look at here. Here this is domain is ABC. Suppose this range is 1, 2, 3 for function f. If inverse, that means range become domain, domain become range. That is 1, 2, 3 is a domain for f inverse function. ABC is the range. For a very good example for graph is here. Look at here. For this is a given line. This is a black one is a given line. For that inverse of this given line is this blue line. That means here we have to draw y equal to x, a line that is axis. From that, from y equal to x line, this is same distance everywhere from this one here. Look at here. So this is a common line between them. Here, for suppose this point A in the first line is 1, 3, the same point A dash in inverse function is that is inverted. Y becomes x, x become y coordinate. That means 3, 1. Look at the same way. Here b equal to 0 and 1. So b dash must be 1, 0. Here this point is minus 1 and minus 1. The inverted also minus 1 minus 1. So it meets. So everywhere the point A for the function, that inverse function is the point inverted everywhere like. So it's called function, and inverse function is this one. Same, look at here, it's a graph f of x, inverse graph is f of x with respect to common line y equal to x. Here also it's a parabola. Suppose this red parabola is the original function f of x. So this one is the blue blue color parabola is a inverse of this. That means this is a common line with respect to y equal to x. Now let us do some more inverse functions, some more examples we'll do. Here f of x. F of x is 2x plus 3. F of x you can write as y equal to 2x plus 1. Then here collect, that is 2x equal to y minus 1. Then x equal to y minus 1 over 2. Here x equal to y minus 1 over x, then converting x is f inverse x, then y becomes x minus 1 over 2. So therefore inverse of 2x plus 1, f of x equal to 2x plus 1, the inverse of f inverse of x is x minus 2. Now next question, look at here an example, more examples for finding f inverse. Next question, f of x equal half x minus 1. F of x is y, half x minus 1. Therefore y plus 1 equal half x, then x equal 2 into y plus 1. Means, so we inverted, that means f of x, y is in terms of x is given, then x in terms of y you have to find. Therefore convert, x is f inverse x, then y become x. So this is a f inverse function. That means f of x equal to half x plus minus 1. Then you can say f inverse is 2 bracket x plus 1. Our next question is on example. Look at here. F of x equal 2x plus y, and g of x, when g of x is 8 minus x over 2. Solve for x. That means suppose a solve 4 gets 4 inverse of x equal 9. Solve this equation. First you have to find composite function f of x. Now first of all 4x is f of g of x. G of x is 8 minus x over 2. Now further f is 2x plus y. Then we have to give that one to 8 minus x over 2 as x plus 5. So this is 4x. So I want to cut here. Then 8 minus x plus 5 is 13 minus x is 4x. Now, suppose let it be this is y equal 13 minus x, then x equal to 13 minus y. Therefore, log inverse x equal to 13 minus x. That means you are converting x as log inverse x, y as x here. That is 13 minus x. Log inverse x is this one. Now our solving log inverse x is 9. Log inverse x equal to 9 is given. Then log inverse x is 13 minus x equal to 9. Then x equal to 13 minus 9. Then x equal to 4. This is the solution. So far we discussed about, look at here. Now here reciprocal function, asymptote about the asymptote we discussed, as well as how to find vertical and horizontal asymptote for some functions. And then further we find inverse function. We discussed inverse function and we give some examples, solving examples for finding a inverse function. We have done. Please subscribe our YouTube channel.